Hey, good afternoon everyone, and welcome to the workshop Decentralized Storage, Build Web3 with Web3. My name is Jessie. I'm from the company Filebase, where I am the senior technical writer, and today I'll be teaching everyone a little bit about what decentralized storage is, how it compares to centralized storage, and the different decentralized storage networks that are available for use through Filebase. And then we'll have a demo presented by Eric from the Nervos network, showing everyone how they can use Filebase in the Unity SDK for the Unity game engine service. So to start off, what is Filebase? So Filebase is a decentralized object storage provider. We are the first S3 compatible object storage provider that allows you to store data across multiple decentralized storage networks. We currently support the IPFS, SIA, Storage, and Skynet networks, with more to come in the future. And we are also an IPFS pinning service similar to Pinata. We offer an S3 compatible API that can be swapped in place of any other S3 API, such as the Amazon S3 API. So we are compatible with hundreds of different third-party file management or backup client tools, as well as lots of different SDKs and pieces of code. And we are currently developing an IPFS pinning API that is still in beta, but it is coming soon. So a little bit about me. I am the senior technical writer at Filebase. I've been at Filebase since September of 2021. I write everything from our configuration guides, Web3 tutorials, all of that is on our doc site, and I also do some of our blog posts, all of our ebooks, our one-pagers, and our white papers. I have a Master's of Science in Information Technology Management, and I have previous experience as a Linux system administrator and a cybersecurity analyst, and I'm a very big advocate for women in technology and women in the Web3 space. I've done Twitter Spaces with Unstoppable Women of Web3, one of the partner companies of Unstoppable Domains, and I really enjoy bringing light to women in this space. So what is decentralized storage? Decentralized storage rethinks the way that data is traditionally stored. So typically, data is stored in what is known as centralized storage, or also it can be referred to as the Web2 way of storing data. That is when data is stored entirely in one place. So whether it's on your local hard drive or on your phone, or if you upload it to Google Cloud or Dropbox, when that data is stored, the file is stored on one server, on one hard drive, in one geographic location. So even if you are backing up data to Google Cloud and it's not backed up to your computer or an external hard drive, it's still backed up to one geographic location, whether that's Google's US East region or US West region or one of their European regions. Wherever it is, it's stored in that one data center. And it doesn't have inherent redundancy or replication unless you specify that you want additional copies created, and usually there's additional charges with that. Decentralized storage stores one file across between 30 to 80 different locations simultaneously. So the way that that's done is through the use of blockchain networks. So if you're not familiar with blockchain networks, a blockchain network is a trustless ledger network that is comprised of nodes located across the world, and the only way that these nodes get onto that network is that somebody chooses to put them onto the blockchain. So everything is manually opted in. It's not controlled by one individual person. Each individual node is controlled by a separate individual person who elected to have that node join the blockchain. Everything on a blockchain is immutable, so the transactions that happen on a blockchain cannot be edited or changed, and the record of each transaction is public, though the content of each transaction is not. So if you upload a file to a decentralized storage network, the record of that transaction and that upload is public, but the file itself is not. So to visualize how decentralized storage works, think about how online orders are submitted, processed, and shipped from large corporations with multiple warehouses all over the world. You go onto Amazon and you place an order for 3 different household items that you need. Once the order is submitted, Amazon determines which houses near you have the items that you've ordered in stock. One item might be in stock in the Orlando warehouse, another might be in stock in Atlanta, Georgia, but the third item might only be in stock in Seattle, Washington. Amazon coordinates these 3 different locations in order to fulfill your order. They source the items from the warehouse closest to you whenever possible, but they don't cancel your order just because one item is out of stock at the warehouse nearest to you. So decentralized storage works like this online order analogy, but instead of an order of physical items, decentralized storage uses files. So when you store a file on a decentralized storage network, it gets broken into small chunks that are distributed among the different nodes on the blockchain network. The number of pieces that the file is broken into is going to vary based on whatever network you're storing the file on, which is typically between 30 to 80 pieces. And then each piece is then encrypted with a special algorithm and then stored across a wide variety of locations around the world. And this process is known as Reed-Solomon erasure coding. When you access or download the file, the process is similar to when your online order is compiled and sent to you. Your file gets pieced together using the parts stored across the world, then sent to you in one package for you to view and download. Only you, the user that uploaded the file, can access it and initiate this process for the file to be compiled for access. But unlike online orders that can take a few days to get shipped to you, your file is ready to be downloaded in just seconds. So when the files are broken apart into erasure-coded pieces, not all of those pieces are required to reassemble the file for access or download. The erasure coding process is a really good way to ensure data's integrity. So for example, on the Saya network, the file will be broken into 30 pieces, but only 10 of those pieces are needed in order to access or download the file. So that means 2/3 of those pieces can be offline or corrupt or stored on nodes that were taken off the network, and you can still access your file. You won't even know that they're offline chunks since it won't access how you view or download your file at all. The erasure coding process also ensures that no file can be accessed without the minimum number of pieces. So each node is only able to store one piece of the file, so no node will ever have access to the minimum number of pieces that are required to access the file, which protects the file's content by adding a layer of security against the node's owner being able to access the content of the files that it's storing. So what are the differences between centralized storage and decentralized storage? Well, centralized storage has a single point of failure since everything is stored in one geographic location. If there is a power outage or a fire or some other sort of disaster or event that makes it so that everything stored in that data center can't be accessed, all of your files are inaccessible to you. Decentralized storage, however, has no single point of failure. So like I just previously explained, you would have to have more than 2/3 of the file pieces offline or corrupt in order for your file to be inaccessible. And since there are so many different pieces stored across the world, it's very unlikely that more than 2/3 of those are going to be offline or corrupt simultaneously. With centralized storage, there is no inherent data redundancy or replication. Any additional copies or backups need to be made manually, and you most likely will have to pay for those additional replications to be stored and maintained. With decentralized storage, since only 1/3 of the pieces of each file are needed to retrieve the file, each file inherently has 3x data redundancy. On centralized storage, one single authority controls how the data is stored and where it's located. So if you're storing data on the Google Cloud, Google has the authority as to how that data is stored on their servers and where it's stored. With decentralized storage, since there's no single authority that controls the data, and the blockchain is a trustless, immutable ledger system, nobody has more control over the data than anyone else on the network. Centralized storage is also traditionally very expensive due to the additional costs that are included, such as server maintenance, data center real estate costs, on-site technician salaries, and electricity costs. All of those have to be factored in when companies are providing a price for users to utilize that storage. Decentralized storage, however, is up to 90% cheaper than centralized storage in some cases, making it a much more flexible and affordable option, while also providing lots of other numerous benefits, such as the inherent 3x redundancy and not having a single point of failure. Data that is uploaded to decentralized storage can only be retrieved by the user who uploaded it. It's secured with encryption such as the cryptographic hashes like 3FISH and lots of other extremely secure industry standard security measures. So there are a handful of different decentralized storage networks in the Web3 ecosystem. Each of these storage networks is similar to the different crypto blockchain networks such as Ethereum or Polygon, where each network has their own native cryptocurrency or token that is used for gas fees and other transaction fees on the network. So the IPFS, or the Interplanetary File System Network, the SIA network, the Skynet network, and the storage network are the decentralized storage networks that Filebase currently supports, but there is also a chunk of networks that we currently don't support but plan to support in the future, such as the Filecoin network and the Arweave network. So why does decentralized storage matter? It is far more reliable than centralized storage since it has no single point of failure. It is geo-redundant with 3x redundancy natively on most of the decentralized networks. It is secure through the encryption process that each file goes through when it is erasure coded. It shares and supports the values of Web3, such as not having a single point of authority, using decentralized technologies such as blockchain networks and cryptocurrencies. And it supports the idea that Web3 should be built with other Web3 technologies, not built on top of traditional Web2 technologies. So the solution to building Web3 with Web3 is Filebase, since Filebase unifies multiple decentralized networks under one interface. We have a simple, easy-to-use web dashboard that allows for easy drag and drop onto any of these aforementioned decentralized networks. We also have an S3 compatible API, which means that it can be replaced seamlessly into hundreds of third-party tools that work with Amazon's S3 endpoint or any other S3 compatible storage endpoint. So it allows for seamless integrations with different SDKs, code packages, and hundreds of different third-party tools. We also offer a proprietary edge caching technology for faster file delivery times, which means that we are faster than some of the other methods of accessing files stored on these decentralized networks. Like if you were to store things on SIA directly yourself and then access them from SIA, it would work in a similar manner, but you would have other things to manage, as well as managing some delivery delays. You would also have to manage crypto such as SIA coin, the smart contracts, and other complexities of going directly to the decentralized storage network yourself. At Filebase, we manage all of those aspects for you. We also don't have a minimum file size, a minimum retention issue, meaning that the files don't have to be retained on the network for a minimum amount of time, and we also don't have any retrieval delays thanks to our edge caching technology, and we don't charge for ingress data or API calls as some other S3 compatible services do. Filebase is also an IPFS pinning service, and all files that are uploaded to an IPFS bucket are automatically pinned to the IPFS network. So what this means, if you are unfamiliar with IPFS and how files stored on IPFS are managed, files that are uploaded to IPFS and are not pinned on IPFS get removed during what is known as the garbage collection process. So during this process, any files that aren't pinned get removed to make room for other files. So if you have a very important file and you upload it to IPFS, it can cause problems when that file gets removed from or during the garbage collection process, because then it is inaccessible. It's no longer hosted on the network. So at Filebase, we automatically pin all files that get uploaded to a Filebase IPFS bucket, and we also replicate it 3 times, so your file not only is safe from the garbage collection process, but it also has 3x redundancy, which is not an inherent feature of the IPFS network like it is the SIA network or the storage network. IPFS is one of the most popular storage networks in the Web3 ecosystem right now. It is widely used for projects like NFT collections and other different digital asset collections. And IPFS is also popular due to the fact that all files that are uploaded to IPFS are public and can be accessed through any IPFS gateway using the file's CID or content identifier. So this makes for really easy file sharing and management of files. It's not great for files that are intended to be private, and so that is why Filebase offers other networks in order to provide private solutions for confidential files, such as files stored on the SIA network or the storage network. All of those files are private and inaccessible, but files stored on IPFS or Skynet can be accessed through public gateways or Skylinks. And so now I'm going to pass it over to Eric from the Nervos network, and he's going to give everyone a demo on how to upload files to Filebase through the web console, and also how to access and retrieve files through the Unity Game Engine SDK.
The first thing we want to do before we even jump into Unity is make sure that we have a Filebase account. So we can just go to www.filebase.com. and you can go ahead and sign up for free. Now, I already have an account, so I'm going to go ahead and sign in. And once you're signed in, you can go ahead and create a bucket. Now, if you're on a free account, I think you can only have one bucket, but I've got a paid account here. And go ahead and create a new bucket, and this needs to be a unique name. And you can use different storage networks here. I'm just going to use the IPFS one. That's the one I'm most familiar with. And once you've done this, you can go ahead and click to open up your bucket. And I'm just going to upload an image here to use in my bucket for my sample. Okay, I've gone ahead and uploaded a Nervos logo here, and we can just click on it to see. We should be able to see it through the IPFS gateway. Oh, yeah. I guess not, because we don't have public access to this, but we can actually get it through our Unity. That won't be a problem. The next thing we want to do is go ahead and jump over to the GitHub account, and I'll share a link for this. But it's www.github.com/EricVanderWaal. So this is my GitHub repo. From here, you should be able to browse the repositories, and in the repositories, it will probably be somewhere near the top, and this is the Unity Filebase SDK. From here, I'm just gonna, you can use this different ways, but I'm gonna do it the most straightforward way for me, which is just go to the code tab here, download the zip file, and I've already done that, you can see here. With the zip file, you're gonna unzip it. Once you have it unzipped, we only really need one part of this project. So you will see something like this. You've got the packages, projects. We just need out of the assets. In the assets, we just need the Filebase SDK. So the next step is to make sure you have your Unity project open and accessible. So in this case, I have a completely blank new Unity project, and this is Unity 2020.3, so this is the LTS version, but this should work on other versions of Unity as well. So I will just go in and grab this Filebase SDK and drop it into my assets. So this might take a second to compile. The other thing we want to make sure that we have as well is that we have Text Mesh Pro, because we use Text Mesh Pro in some of the sample scenes here in Filebase, but you're most likely going to need that anyways. So to get that, we can go into the Windows, we go into the Package Manager, and we can see, okay, Text Mesh Pro is already in here. If it wasn't already in here, go ahead and install that, which you might get some errors if you don't already have Text Mesh Pro. Now we are ready to go ahead and code using Filebase. At this point, you can pat yourself on the back. You're about 1/3 of the way there already. Now we're just going to open up Filebase SDK, and you can see in here we already have the AWS SDK, which is what Filebase uses to handle all of its connections. So I've brought in here just the essentials of the AWS SDK that you need to run properly. So the full AWS SDK is actually much larger, but since we're not going to be using any of it, I didn't actually include any of that. Now from Filebase, I have some sample projects you can check out with scripts, as well as we have some main scripts that you're going to need. If you want, you can go ahead and delete the sample projects, but I would say hold on to them just for now until you feel comfortable using this. So looking at the scripts, we do need to change one right off the bat, and we can go ahead and open up this pass one. And I'm using Rider here. You can also use Visual Studio, of course, or any other thing that you want. And what you're going to need to change here is your access key and your secret key. You can see two are already here, but these have long since been changed. But this is essentially what it should look like, and we need to get this from the Filebase website. So just going back to the website here, we can choose access keys. And you should be able to get your key here and your secret. So you want to copy these two in. So one should be shorter and one should be longer. So you should be able to see that pretty easily. And you can go ahead and copy these in here. This will be used to make your connection to Filebase. Now we can just go ahead and remove this. Actually, none of that's necessary. And don't forget to save it when you're done. Once we're back in Unity, we can start coding our project. And to begin, I'm just going to do something very simple, which is get all of the objects from a single bucket. And I don't want to, start too hard. We'll go there. Once we've done that, what we're going to do is for the next step, we're going to take a screenshot and upload that data into Filebase. But first, let's just start with something a little more simple. I'm going to create an empty game object, and we can just call this sample. I'll call mine sample get all from bucket. You can call this whatever you want. It really doesn't matter, but always make sure that the name of your script here in Unity matches the name of your script internally. So we'll see what that means. So the name here should be matching, otherwise it's going to throw an error in Unity. We don't need any update function, so we can remove this, but we will start coding in the start function. To start off, we're going to need to give it our bucket name. So I'm just going to create a serialized field, which means that it's exposed to the editor, but we can still keep it a private string. And I'll just call this bucket name. And we can go ahead and save this. I like to save a lot. And actually, what we're going to do is just a little change up here. So we've got void start, but we're actually going to make this an async void start. And you may not be familiar with async programming because it's not that common in Unity at this point. But what it does is allows you to run things in order essentially without blocking what else is going in the game. So for example, if we're like downloading a whole bunch of files or something, we want to make sure that it's not blocking the rest of the Unity from running. So this is a way of accessing multi-threading. And traditionally this is done in Unity using coroutines or similar ways. And however, the way that the AWS SDK works is it requires multi-threading. So we can just start multi-threading using async void start here. And we want to go ahead and get our client connection first. So we're going to be using Amazon. So we're just going to say Amazon S3 client here. And we can call it client. We can call it whatever we want. And now we're going to start using Filebase. So we're going to say Filebase dot, and it gives us a bunch of options. We're going to use Filebase utilities, utils dot, and get client. So it's simple as this. It will generate our client using the pass that we already gave it with our secret keys and everything here. And it will pass back the client that we need to essentially call any command from Filebase now can just use this command. So once we've done that, we're going to create another method here. And it also needs to be async. And with async, we always need to pass something back. So we're just going to say task. You can say get all objects and debug. That's basically what we're going to do. And we want to pass it the client here. Now it's going to give you an error here. It's going to say, do you need systems threadings task? So we can just choose this. And I'm going to say, yeah, import. So now we should be using systems threadings task. And our error should be going away. Okay, so we want to call this here right at the start. So we're going to say await get all objects and debug, and we're going to have to pass it the client here. So we already have this here. So we can just say client. And now we are passing the client into this function here. Now, when we're doing something like this, we want to make sure that we're using try catch in case it throws any errors, because it's certainly possible to throw errors if we do something unexpected. Maybe we're not connected to the internet, maybe it's the wrong bucket, or there's all kinds of things that could go wrong. So we just want to make sure that we try and catch those. So we can just say try like this. And we can set up our catch right away. So try catch always takes on this formatting. And we also want to check for any exceptions that might happen. And you can give the exception whatever name you want here. It could be like exception. E is sort of the common way of having this. Okay. And I'll deal with this right at the beginning so we don't have to come back to it. I'm just going to say give us a debug, oops, not destroy. We're going to say debug.log error. So we wanted to throw in an error. And we could just say, you know, error has occurred plus. So we concatenate these together. And we're going to say e dot. And we have all these options here. We're going to choose e.message. So it's going to show the error message if it catches an error. Okay, so for the part that we actually want here now is how do we connect to the bucket? So we've passed in this client and we want to actually use it in some way. And let's take a look here. So I sort of like to do it this way. I know it's a bit backwards, but it helps me to figure things out. So I can type filebase dot and then see all of the options, right? And it's a type of transfer. Nope, we don't want a transferring thing. We want to check the buckets. So we're going to choose bucket dot and see all of our options here. And we can see delete bucket, check if a bucket exists, get all buckets. We want to get all the objects in a bucket, right? And what it's going to need is the client. Essentially, it needs to log us in, as you can see. And then it's going to need the bucket name. So we have client, bucket name. So we can go ahead and pass it the bucket name. Now we need to save the output of this in some way. So we can just say var, say bucket objects, bucket type equals. And we need one more thing here. Because we're working with async, we want to await this task. So we're going to say await just like this. So this is an asynchronous task, therefore it needs the await keyword. Now you can see here with the code hint, it tells us this is a list of S3 objects. So I can actually change this variable to be explicit. I personally like my variables to be explicit. It's easier to type the var keyword, of course, but when I look at it, I can see what's going on really easily here. So we have these S3 objects. Now let's take a look at the source for this. So we can just say go to declaration. So there's different ways to do this. Let's have a look. So we could check it out and see what's in the what it's going to pass back. So it's going to pass back like a bunch of different things. Okay, so we're going to try and get this, and then if it comes back, let's do a little check. And we're going to say if bucket objects is, let's do the opposite. If it's null, right? Or if the bucket objects count is equal to 0. So if that's the case, then we can say like debug log, and we could say like no objects found. And then we're going to return out of this, so it's going to end the method. Okay, otherwise, I think we can assume we basically have something. So what we need to do, though, is essentially we have a list. So we want to iterate through this list. So I'm just going to say, we can just use a for each here. And for each object in this list of objects, we're just going to say debug.log. And there we go. Object was found, named. We're going to use a plus to concatenate those, and we can say object dot, and we're going to use the key. So the key is essentially the name of the object. Okay, so this should be it to basically check for an object. So let's take one more quick look through it. So we have a bucket name, and on start, we have to make sure it's an async void start because we're using asynchronous coding here. We are going to get the client by saying Filebase utility get client. With that, we're going to pass it into our variable, or sorry, into our function. And, I just named this get all objects and debug. We can call it whatever we want. I'm going to pass in that client. Then we're going to make sure we use a try catch statement over everything. And we're going to catch any exceptions down here. And this is just a standard format. This is something you basically have to remember. Try, catch, and then have the exception. You can go ahead and Google it and paste it if you need to, or check one of the samples. Then once we're in the try section here, we're going to await, and we're going to use Filebase bucket and get all objects in the bucket. So if you're using virtually any C# IDE here, you should be able to see what you need to pass in. In this case, we need to pass in the client and the bucket name as the string. And it tells us get a list of all objects within a specific bucket by name, return null for no results. So we're going to check to see if it's null or if the count is 0. If so, no objects were found, return, exit this, right? Otherwise, for each object in this bucket, we're going to print out that object key. So let's go ahead and save this and try it in Unity. Now don't forget to put in a bucket name here. And let's jump over to our console and hit play without a bucket name and just see what happens. Okay, so it throws an error and says no objects were found, and you can see this was from the try catch. The try catch says data missing. Did you add a client bucket to the name? Or actually, this was caught further up the line. So that works too. Okay, so let's go ahead and copy and paste our bucket name in. And this is my bucket name. Paste that in, clear, play. And I'm getting access denied because I did not change my secret key properly. Okay, let's do it one more time. I changed my key, so hopefully this is correct. And there we go. Object was found named Nervos logo white.png. Awesome. Okay, so let's take it from the other way around here. What we want to do is upload something, but we're going to take it one step further by taking a screenshot and uploading that data to Filebase. To do that, I'm going to add another script here, and we'll just call this sample take screenshot. Open that up. And just like before, we're going to be using async, so we can just start off by saying async here right at the very beginning. So let's add a few variables here, and I'm going to use serialized fields. I really like to use serialized fields just for encapsulation reasons. So we can say private string, and we're going to give it a bucket name again because we need to decide where to upload it. You may only have one bucket at the moment, but it doesn't know that, so you need to tell it which bucket it's going to go to. The next thing I want to do is I'm going to add a button here. Oops. And this button is so I can click when I want to take a screenshot. So you'll have to add using Unity engine.ui to use a button. And I will just call this button. And I think that's all we need. We really need a button to click to take a picture and a bucket name of where to upload something. And just like before, we need a client. And I'm just going to save this as a variable this time. So we can just say private Amazon S3 client. That's what we need. And we can call this client and just save this up here. This way we only need to get it once, even if we're going to use it a couple of times. At the very beginning, I want to get this client, filebase.utilities.getClient. And after that, I want to add a listener to this button. I'm going to listen to this button for clicks. We could certainly set this up through the UI in Unity, but it's also pretty easy to set it up by code. So I'm just going to go ahead and do that. So I'll say button.add listener, or sorry, I should say on click. So when it clicks, we're going to add a listener for a, let's say, take picture. And we need to create a function for this. So we'll say private void take picture. So when this button is clicked, it will take a picture for us. And to do that, then we want to kick off taking a picture. So we're going to say private. We're going to use async here as well. Task, take screen shot, let's just call it, right? And just like before, it's going to throw us a little red flag here saying you need systems threadings task. So I will do that. And we're going to go ahead and take a picture. And thankfully, Unity gives us sort of a way of doing that out of the box. We don't have to necessarily come up with something. And we can just say screen capture. So we can see this is a built-in Unity function. And it doesn't give us a lot of options here, so we're just going to use capture screenshots. Now, for capturing the screenshot, we have two options that we can add here. One is we need the sort of file name, and then the other is if we're going to make any essentially size adjustments. So we don't have a file name or a path yet, so we should generate that. So let's take a step back and do that first. And for me, I'm going to give it a date as the file name. So we can do that. We can just say, we can just call it the picture name. Could be my pic, right? And then we're going to concatenate this together with something. And I want to choose a date time. And we're going to say now. And I want to do it to a string. And you could do all kinds of formats to this. I'm just going to go day. And I have this memorized, so you can copy and paste this from somewhere. You don't have to use mine specifically. I think you could probably even give no format, maybe just like this. Let's try that even. But we also want to make sure that we add on the end to this, so .png. Okay, so picture name. So this will be a string. Let's add it up here. Private string picture name. That should stop complaining down here for us. Okay. Then the next thing I want to do is actually not just give it a name, we want to give it a path, like where it's being saved in the system. And this will help us to retrieve it later. Otherwise, it'll be like hard to find. And I've created a little utility for this to make this process a lot easier for us. And we can go ahead and I'll just go up here again and say private string save path. So we'll create a save path for this to save as well. So we'll say save path is equal to, and here is another Filebase utility. So we'll go filebase.util. And in here we have one called generate path. So it says generate a path by bucket name and object key name, including the application persistent data path. So what it basically is taking is we see the bucket name, the object key name, which we have up here, we just called a picture name. And it's going to pass back a path all the way back down to the persistent data path. And we'll see this in a minute. So let's generate path and bucket name. So what's the bucket name? It's just we pass it the bucket name variable and the picture name. And it's going to give us a save path. So we can go ahead and pass the save path into the screenshot. Now we know where it's going to end up being. And let's do this. Let's just say debug.log save path at, and we can find out where it's being saved. Save path. I also want to double the size of this being saved. So I'm just going to say supersize times 2. So great, we're moving along pretty quick here. We almost have our screenshot done. One thing I want to do after this is sort of a hard-learned task about taking screenshots in Unity is if you don't wait at least one frame after the screenshot before you try and do something with it, it's going to throw an error. So we basically have to force Unity to wait at least one frame. So the way to do this with asynchronous programming, and again, if you don't know this, you basically have to look it up. You just can't, guess. Is we're going to say task delay 1, and this will make it wait 1. Okay. Then we want to, upload this to Filebase. So let's create another method for this, and I am chaining these together, which is not super great, but it's sort of the most efficient way to do it right now. So we'll say private async. We're going to keep doing asyncs task because we don't need to return anything, and we're going to say upload to Filebase, right? And so we need to call this function once all of this is done here. Um, So yeah, generating a path, we don't need to await this. It's not an asynchronous one, so we don't need await here for this variable. The only really thing that's here that's async that we're using, frankly, is just awaiting 1 frame delay. Okay, so then we want to call await upload to Filebase. And now we're calling this function down here. Okay, I'm actually going to do a little debug log here just for my own sanity. And you don't want to do this in production, but we can say something like trying to upload to Filebase here, so we know that it's like got to this function. And what we can also do here is we can have the button, now that we've got that button, we can say button interactable is equal to false. So we can disable this button while this is happening, so people are not like jamming on the button, like boo, 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 right? We don't want that to happen. Now, just like before, we want to make sure we wrap this in a try and catch here, just like before, no change. And I want to catch any exceptions here, and I'll just call it E for short. Again, we can call it whatever. And if we have an exceptions, I want to say debug.log error, and I can just say error is plus to concatenate, and then e.message to show the whole message. Okay. Next, we want to do sort of the meat of the operation here, which is upload something. And to do that, we're going to need the client, which we already have. It's saved up top. So I'm going to, just browse my way in here. So I'll say Filebase. And this time I'm going to use transfer because we don't want to work with a bucket. We want to transfer something. And from here, we can see a couple of options. The first option is download object from bucket. We have upload object to bucket and upload object to bucket by path. So in this case, you can see this is essentially just a helper method that you can pass it the client, the bucket name, the object name, and a path. And this one we can give it some sort of like a custom path, right? This time we're actually just use upload object to bucket. And yeah, looks good. Okay. So because we've saved it into this bucket path pair, specifically using this utility, it will know where to find it here, right? So it'll know where it's saved to. So let's just read the instructions here. Upload to a bucket by object name or object key name and bucket. Object should be stored at application persistent data path backslash bucket name backslash object key name. So yeah, we're already using this. This generates it for us automatically, so we don't have to fool around with any of that. Okay, so let's give it the client, then the bucket name, and lastly, we want to give it the picture name. So this is the key. And from this, it's going to know where to find it. So we need to save some kind of an output from this. So let's see what it passes back. So this passes back a bool. So we could just say var success is equal to, and we want to go ahead and add an await here. Now we could change this to be explicit, so we know that a bool is coming back. We can say if success is equal true, I should say equal is true, then we can say debug.log, object has been uploaded successfully. If I could spell, then we could say else debug log upload fail. Okay, close enough. Let's just fix that. Now there is one last thing we can do here, is we could essentially get the path of this, although we may not be able to see it because this is not a public bucket. So public buckets need to be, I think, on paid accounts. So we're using a free account, but we can try it anyways. So yeah, if this is successful, we have a little tool built in here that we could say var public path is equal to, and let's just use await filebase dot utility, and we're going to say get base URL. And what we need to do here is pass in the client again. We're going to pass in the bucket name, and we're going to pass in the picture name. And we'll just debug out this information as well. Object can be found at, so we want to know where we could get a copy of this, right? So public path, and there we go. So we can save all of this and jump back into Unity. I'm going to remove this old script that we're no longer using, and we're going to have to give it a bucket name. So I still have this, paste that bucket name in there. So we also need a button. Obviously, I don't have a button yet, so we can go to UI, and I like Text Mesh Pro button. Yeah, import some essentials. We might need those essentials. And I've got a pretty simple button here. I'm not even going to bother messing around with it. But I do need to go back to my script here and make sure that we drag the button in here. Otherwise, it's going to throw an error for sure. We didn't do any checks to see if the button, was existing or anything like that. I didn't do any null checks. We're just doing it pretty quick. So go ahead and play. Hopefully we didn't code anything wrong. We can click this button. And nothing happened. What did we do? Okay, so we click the button and we're looking here. It calls this function, which doesn't call anything. So it should call this function here. That's because when you can't add a listener, I don't believe, to an async function. That's why I'm using basically like a proxy function to call this one to call an asynchronous one. So we're just going to say take screenshot. That's essentially why there's an extra one. I also thought there's also something else I missed, which is we turn the button off, but we forgot to turn it back on. So at the end of this, we should make sure that we turn the button back to true so people can click it again. So we'll save and then try this again. And it seems like we're throwing an error here, so this is a good chance to check it out. And I suspect this might actually have to do with this part here. So let's go ahead and actually give it a specific format. And you can see it like basically suggests some formats here. And we want to use one that has like basically down to the seconds. And so maybe I'll just type my own here. So I'm going to go day, dash month, dash year, dash hour, dash minute, dash second here. So I don't want any spaces. I make sure that it's all like dashed out here. So you can go ahead and like basically look up this date time now formatting if you want to see, or you could essentially just copy mine. And I'm hoping this will fix the problem here. Guess we'll find out. Okay, this time it looks better. It says object has been uploaded successfully, and the object can be found here at this URL. Cool. So the reason that it failed before, I think it's just a formatting issue. It had spaces in the name. And the reason that I'm using the date, and you don't have to use a date necessarily, I'm just using the date because then every picture I take will be unique. And so it won't have the same name as any other picture before. So you can see the name here right there. Okay, so object can be found at this URL or at this path. So I'm going to copy it out and we'll stop this. And I'm pretty sure because it's not a public bucket, you can't see it. If you have a paid account, we could go ahead and then just turn off private. Yeah, so that might take a little time to refresh, but what we can do instead is just go over to Filebase. We can open up the Nervos Filebase tutorial, which we were using, and we can see our picture is right there. And if we click it here, we can see our screenshot in all its beauty. So that's a pretty straightforward way to upload images and take a screenshot to Filebase, which I hope is helpful to you. And you know, I think the first time you do it, it might take a little bit more than you thought because you have to use essentially a try catch and an async and a wait. And this unfortunately is necessary for Filebase. Or sorry, not necessary for Filebase, it's necessary for Amazon SDK, which Filebase is using in this case. Now there is the one drawback to this, which is essentially it does not currently work in WebGL, because WebGL is essentially not multi-threaded. It doesn't support multi-threading. There is some experimental support, and so hopefully in future versions we can get this working. But for now, it's like PC, console, mobile, or any other way, you can essentially deal with Filebase in this way.
Thanks, Eric. That was a great demo of how to use the Filebase web console, but also how to use Filebase through the Unity Game Engine SDK. If anyone wants to get started today with Filebase, you can use the code Web3Welcome for 1 terabyte of free decentralized storage for your first month when you upgrade to a paid account. And if anyone has any questions, I'd be more than happy to answer them for you.